How are you today? I hope all of you are doing well. In this video, we are going to learn about factors. The title of our lesson today is Understanding Factor Concept and its Application. And this topic is important factors because are not only used in mathematics but also in physics, sports, navigation, transportation, and many activities in our daily life. By learning factors, we can understand how to describe movement, direction, force, and many other quantities more clearly. So let's start our lesson. And before we discuss the material, let's look at the learning objectives. After watching this video, students are expected to be able to first explain the meaning of a factor, and the second one is to distinguish between scalar quantity and vector quantity, and third, represent a factor using an arrow, and fourth, find the magnitude of a factor, and the last one is the fifth, is the magnitude of a factor using a simple formula and explain some application of factor in daily life. In Indonesia, it means that after this lesson, students should be able to understand what a factor is, how to draw it, how to calculate its magnitude, and how factors are used in real situations. So, please pay attention to explanation today, because at the end in this lesson, you will understand the factors are actually very close to our daily lives. And now, let's begin with a simple situation. Imagine that a student walked a 5 meter to the east. Now I have a question of you guys. It is enough if we only say 5 meters, or do we also need to know the direction? Please think about it for the moment. What do you think, guys? And the answer is we need both information. We need to know the distance, which is the 5 meter, and we also need to know the direction, which is 2 east. This is a basic idea of a vector. A vector gives us two important pieces of information. Is how big something is and where it is going. And in Indonesia, we can say that a vector tell us besar and ar. And now let's look about definition of vector. A vector is a quantity that has both magnitude and direction. The word magnitude means the size, value, or length of the vector, and the word direction means where the vector points. For example, if I say 10 meters to right, this is a vector. Why? Because it has magnitude and direction. The magnitude is 10 meters, the direction is to the right. So remember this important sentence. A vector has a magnitude and direction. Okay, remember guys. And before we continue, we need to understand the difference between scalar quantity and vector quantity. A scalar quantity is a quantity that only has a magnitude. It does not have a direction. For example, it's a mass, time, temperature, distance, and speed. If I say the temperature is 30 degrees Celsius, it only gives the value, there is no direction, so temperature is scalar quantity. And now let's look at the vector quantity. It's the difference. A vector quantity has both magnitude and direction. For example, is a displacement, velocity, force, acceleration, and momentum. Let's compare two examples, distance and displacement. Distance in scalar because it only tells us for an object moves. For example, is a student walks 5 meters, but displacement is a vector because it tells us for how far and in what direction an object moves. For example, is a student walks 5 meters to the east. Like that, okay? Okay, now let's learn how to represent a vector. A vector usually represented by an arrow. The arrow has had two important parts. The first is the length of the arrow show the magnitude of the vector. Second, the direction of the arrow show the direction of the vector. If the arrow is longer, it means the vector has a greater magnitude. And if the arrow points to the right, it means the vector has a direction to the right. And if the arrow points upward, it means the vector has an upward direction. For example, if we draw an arrow from point A to point B, the vector starts from A and ends at B. This can be written as a vector AB. So the arrows help us understand the vector is visually. And the next one is the vector notation and component. Now let's discuss vector notation and component. A vector can be written using a letter with an arrow above it. For example, vector v can be written as v with an arrow above it. A vector can also written its component from, for example, v equals open bracket x comma y close bracket. Here, x is the horizontal component and y is the vertical component. The horizontal component shows movement to the right or to the left, and the vertical component shows movement upward or downward. For example, if a vector is written as v equals open bracket 3, 4, close bracket, it means the vector moves 3 units horizontally and 4 units vertically, like that. So, the component from help us calculate and describe the vector more easily. And let's learn how to find the magnitude of a vector. The magnitude of a vector is the length of the vector. If the vector has two components, x and y, we can find its magnitude using the formula. The magnitude of vector v equals the square root of x square root plus y squared. It's mathematical form. Let's look the screen. That is. And this formula comes from the Pythagorean theorem. Why? Why is it come from Pythagorean theorem? Because when a vector has horizontal and vertical component, it's from a right triangle. The horizontal component is one side of triangle, the vertical component is another side of the triangle, and the vector itself becomes the hypotenuse. So, to find the length of the vector, we use the Pythagorean theorem. And let's move to solve an example problem together. The problem is, a vector has a horizontal component of 3 units and vertical component of 4 units. Find the magnitude of the vector. And look at the solution. From the problem, we know that x equals 3 and y equals 4. The formula is from the before screen. Now we substitute the value of x and y of the formula. The square is 9, 4 squared is 16, 3 squared is 9. So we get this is 9 plus 16 is 25. The square root of the 25 is 5. And so the magnitude of the vector is 5 units. And this example shows that we can use a mathematical formula to find the length or magnitude of a vector. It's too easy to calculate, guys. And now let's discuss the application of vector in daily life. Vectors are not usually used in mathematics. Vectors are also used in real situations. The first example is a navigation. When we use a map or GPS, we need to know both distance of direction. For example, go 100 meters to the north. This is a vector because it has a magnitude and direction. And the second example is a physics. In physics, force is a vector. When we push a table, the force has a certain magnitude and direction. For example, we push the table to the right. And the third example is the sport. When a football player kicks a ball, the ball moves with the speed and direction. The movement of the ball can be represented as a vector like that. And the fourth example is a transformation. For example, is a basic example is a car moves 20 kilometers from the east and 10 kilometers to the north, and this movement can also be described using vector. It is the same thing. So vectors are usually because that they help us to describe movement, force, and direction. And now let's read some mathematical expression. And this expression, I will not read all of them one by one, but you can pay attention to the table on the screen to see English term and their Indonesian meanings. You can see the complete English and important meanings in the table on the screen. Okay. And now let's review some vocabulary related to factor. The first inspector is in Indonesia is a factor. The second word is magnitude, which means besar or nilai. The third word is the direction, which means arah. The fourth word is the component, which is a means component. The fifth word is displacement, which means perpindahan, and the other one. In the slide, we can have some important vocabulary related to factor. Some of the main terms are the factor, magnitude, direction, and component. From the other term, you can see the complete list on the screen. This vocabulary helps us understand and explain mathematical idea in English and Indonesian. And thank you for our lesson today. Thank you for watching this video. I hope this explanation helps you to understand the concept and application of a factor. See you in the next lesson. Goodbye.